We're recording and everything, so let's just do it. Hey, welcome everybody to the Sustainiacs. I'm Michael Vincent. I'm the Sustainiac every week. My guests are always Sustainiacs too, but not on the show. My guest Sustainiac is Mike Hemman, and he is president at Netafim over, well, it should, I guess it should just say North America, right? But it says Canada and USA, correct?
Yeah, that's right. Yeah, I lead the business for Netafim. We're an agricultural irrigation company. Global company, but I lead our business here in North America. And Netafim's part of a larger company called Orbia that is focused on sustainability in many different arenas, many different industries, et cetera. But we are the precision agriculture side of Orbia.
Oh, okay. Fantastic. So the precision agricultural side of Orbia, right? So what does that entail? I see all the agricultural behind you. I think everybody would figure out, hey, and it says, grow more with less. And I know what some of that is. I don't know what all of that is.
Yep. So the primary business that this company is known for, and what we are built on, I'll say the majority of our revenue and the base of our business is around drip irrigation. So Netafim is a company that is headquartered in Tel Aviv, Israel. And this is the company that actually was able to invent drip irrigation. So think about farming and trying to farm in a desert environment. Doesn't work very well. So you have to find a way to deliver water and deliver water efficiently in water-starved areas. That was the birth of Netafim and the birth of drip irrigation.
So Netafim in Tel Aviv invented it, basically, the technology to do it.
Correct.
Was it always?
That's correct.
Did it have to? Okay, so drip irrigation is through plastics, right?
Yeah. So what we have is we have polyethylene tubing, and the polyethylene tubing will deliver water directly to the roots of the plant. So if you think about how irrigation is typically done, or how irrigation has been done in the past, most of it is furrow irrigation. So essentially what you're doing is you're planting plants in a seed row. They're typically on an elevated bed, and in between those elevated beds is what we would call a furrow. And then what happens is you literally just flood water down that furrow. So if you think about it this way, you start on one end of the field and you're going to the other end of the field. It's inefficient. You're using more water than what you actually need to use to grow the crop. So now if you can think about a drip tube, and you can think about a very specific emitter, which is the device inside of the tube that controls the flow rate of how much water gets to the plant. But instead of pushing water across every bit of soil, you literally drip water exactly where the seed is and exactly where the plant is. And you can turn it on and off depending upon the needs of the plant. You can utilize it daily. You can utilize it weekly, hourly. It's really the ability to give exactly the amount of water to a plant when it needs it the most.
No kidding. And so, and these are, I mean, I know of others that produce the tubing, right? But I've never, interviewed and talked about how that tubing was developed and how it actually, it's rolled out on top of the mound of plants, right?
It can be on top of the surface where the plant, It can actually also be underground. So for instance, we have many installations that have been underground for over 20 years, and becomes a permanent situation there. The difference and the benefit there, though, is think about transpiration of a plant, and think about humidity that you're going to have in the environment and water that evaporates. So in a very hot day, if you're delivering water on top of the furrow where the plants are, some of it's going to evaporate. But if you're underground, you don't have that evaporation piece. So it gives even more sustainable use of that water, and allows all of that water to be delivered directly to the root of the plant as well, so it doesn't have to seep down through the soil.
I got you. So in this case, so are these rigids or are these flexibles?
It depends on the application.
Right. So underground is probably rigid, right?
It's not rigid like a PVC pipe. It's still very flexible, but it's a thicker, we call mill thickness of the pipe, versus something that you might use on top of the ground in a lettuce field. That's going to be a lot thinner, because that's a short crop. A lettuce crop could be a 45 to 60 day crop. If you're putting this in an alfalfa field, let's say, you're going to have an alfalfa field that's going to be in production for 3 to 6 years before you have to go do something different with that ground.
Gotcha. So you do both of those. So when you're talking about the short crops or the one like lettuce, those are the drip films or the drip tapes, right? They just kind of roll out like a hose, and they're flat, and then you just run water through them, right? And
correct. And I think so. This is a great segue to talk about sustainability, and we want to talk about something that we have pioneered in that specific market, but we're taking across all markets. So the bulk of the lettuce that is grown for consumption domestically is grown in the Salinas Valley of California. They call it the salad bowl of the world. Super healthy soils, super productive soils. The environment and the weather is conducive to growing lettuce and other cool season crops. And so it just for years and years and years been the salad bowl of the world. So what they've done is, what used to happen is they would take the drip irrigation tubing, they would roll it out, they'd have the plant, they would plant the lettuce, they'd roll the tubing out. It would be time to harvest the lettuce, let's say 60 days later. And so instead of tearing up the drip tubing in the field with all the equipment for harvesting, they pull it out of the field, they harvest. Now it's time for the next planting. They put it back in the field, do it all over again. One of the issues that's happened is the cost of labor. And so with the cost of labor, it became cost prohibitive for the amount of people that are needed to roll that out and repair that drip line. So farmers, being innovators, decided there's got to be a better way to do this. And so the better way to do this, they still wanted to utilize drip irrigation, there was a thought to move towards a horrible name, single-use solution. So now
throwaway culture. Hey, look at Life magazine from the 1950s, man. Life is solved. We got plastics.
Exactly.
Use it, throw it away.
And so this is what was ending up happening is you get to the end of life of this drip line in 60 days or so, and now it's trash. It's no longer needed. So we stepped back and we started interviewing farmers, talking to farmers and saying, there's got to be a better way to do this. And what we did is we led with our pocketbook, we led with our innovation, and we built a recycling plant. So we have a recycling plant that sits here in California, and we developed a whole new product that we call Regen. So just like regenerative agriculture. And what we do now is we sell a product to the farmer utilizes that product, and instead, when he's done, instead of taking that product and coiling it back up and then using it again, we have a machine that will extract that product from the field, put it in a big tight bundle, and then we take that bundle from the farmer. Netafim comes and picks it up and takes it away from the field. We bring it into our recycling plant, and we recover all of the polyethylene that went into the production of that product. We then repelletize that polyethylene, and we bring it to our production facility, and we take that recycled polyethylene resin and rebuild the product. Then we ship that same product back out to the farmer as a cycle, so that over and over and over again, we can recover the polyethylene that's being utilized within these drip tubes.
That's fantastic. And how many times can you do that with the, can you recycle it? I mean, is it 100% recycled that comes back out? Or you have to do a mixture, right? Because it degrades eventually, right? Doesn't it?
It's a mixture of what we would call virgin resin plus recycled polyethylene. And even that mixture, though, the other thing that goes into that is you have virgin resin, let's say, that has been produced and comes straight from the large resin manufacturers like Dow. But the other thing that we do within our production plant is we recover 100% of any scrap material that we manufacture. So anytime there's a defect, we have an internal process where we're able to do the same thing that we're doing in the recycling plant. Now, of course, it's a cleaner process because you don't have soil and rocks and everything else on it. It's just coming off production scrap. So you essentially got 3 types of polyethylene, let's say, that would go into it: virgin, the recycled from the plant, and then field recycled is what we would call it.
Yeah. I mean, the only reason I mentioned that it's a mixture is 100% recycled back into the same product. You start to lose, right? The polymers don't have the same strength, et cetera. It starts to degrade after a while. So you have to There's limitations to these things, although they're fantastic. Because is it not true that like in certain countries or even in the United States, they just plow it under? Some of them, don't they?
They used to burn it, actually.
Yeah.
I mean, not in California, but in some other states where maybe the regulations are not as robust as they might be here. But
right.
Yeah, it becomes a waste stream if you're not managing it correctly. So one thing that happens often, maybe not often, but one thing that happens is there are other manufacturers that offer recycling programs. But what they're doing is they're taking the material out of the field and then they're selling it to a recycler. Now, where does it go? Where does it end up? Does it get shipped overseas to Asia? What happens? We're the only company that has a 360-degree fully owned process where we touch that product and we know exactly where it's at every step of the way through our own facilities.
That is fantastic. That is fantastic. And so do you do I would guess the semi-rigid or the more rigid ones, if it's time to replace it, you can recoup that as well, right? I mean, those resins could be recouped as well. It's just not on as quick a cycle, right?
Yeah. So in the lettuce, you might have you would certainly have 2, sometimes 3 crops per year. And if you think about an almond orchard in the Central Valley of California, that's typically going to be installed for 20 plus years. So at the end of life of that, same thing can happen. We take that tubing as well and recycle that tubing as well, but it doesn't get replaced as often.
Right. Yeah. Because it's a longer cycle, like you said before. It's usually, its life is much longer, right? It has to cease functioning. It's not a process of crop rotation. It is the system fails after a while. Everything fails after a while. You have to replace it, right?
Correct.
So is tubing, do you guys get into flexible plastics as far as, the poly mulches and hoop house films and silage and that type of stuff? Or you strictly stay with the drip tapes, etc.?
The drip line, we also do automation, we do valves, we do filtration, anything that would go into an irrigation system. So automation, so here's the connectivity on automation on sustainability. So what can happen oftentimes is people have to decide how and when they're going to irrigate their crop. So just like you need a certain amount of water per week, per month, per year, per lifetime. No, you probably don't sit down on Monday morning and sit down at your kitchen table with 8 gallons of water and say, let me drink all this water because I need 8 gallons of water for the week. Right?
No, usually not. I usually space it out.
But
in fact, I'll tell you what, once I was in Cleveland, Ohio, and they were talking about, and this was probably like 15 years ago. There was a water challenge, right? Chugging water, and somebody drowned drinking water, right? So you can't drink 8 gallons at once, right? You did.
Exactly. So think about the way that farming used to be done with furrow irrigation. They would say, oh, I need approximately this much water for this duration of time. I'm going to put a whole bunch on all at one time. And then in another week, 2 weeks, I'll put a whole bunch on again. So what's happening with drip irrigation now is, especially with automation, is we have tools that have soil sensors that sit in the field. And the soil sensors then connect back up to a broader network. So we can now overlay site-specific data about how much moisture is in the soil, the weather predictions that are happening, even demand on the energy grid to figure out when is the least expensive time to pump and utilize electricity to pump the water. All of this now goes into a cloud and is overlaid with what we call a crop model, which does a mathematical equation that says, based on the stage that the crop is in, the amount of moisture that's in the field, and the weather, it needs X amount of water. Now, all of that goes back to a system that automatically turns on and off the irrigation system. So it delivers water only when the plant needs it. I'll give you a crazy example. Last week, I was with a raspberry grower, and the raspberry grower utilizes this technology in such a specific way that they may actually microdose irrigation 45 seconds at a time, 18, 25 times during the course of the day, so that the plant can take in exactly the amount of water that it needs at that very specific time instead of just dumping a bunch of water on top of the plant.
Oh, yeah, because you're wasting that water. It's going away. And you said it takes into account the weather. Is it taking past, or are you talking about it is taking input from the weather forecast?
It's both, right? So there can be a weather station in the field that's very site specific, or it can connect to a network of weather stations to look backwards. And then it's also taking prediction models about what the weather is going to be going forward. And it's just constantly running a calculation and saying, based on what has happened and what we think is going to happen, here's how much water the plant is going to consume. Therefore, we need to deliver X amount of water at this time.
Gotcha. So in my neck of the woods right now, your systems are probably trying to figure out how to get moisture out of the ground with Helene about to hit us.
Yeah, exactly. So this is like an automatic sprinkler system. Think about when you've walked out and it's raining outside and somebody's sprinklers are on, and
it drives me crazy. I see it all the time in my neighborhood. But even when I'm looking at the weather forecast and somebody's sprinklers are going off, I'm like, you realize we're going to get 5 inches of rain this weekend, right?
Exactly. Yeah. So this is how the automation part of our systems work as well. Another neat thing that we do, I'll share a little bit about what we call our SDIE system. So SDI stands for subsurface drip irrigation. So this is going to be the flexible pipe underground.
Oh yeah, okay.
Yeah, and E stands for effluent, and so specifically cow manure. Okay, so
nice.
so we are working with dairies, and the dairies typically have feed that they plant to feed the cattle. And so it's typically some kind of forage crop, silage crop. It could be alfalfa, different types of silage crops. They have a massive problem, as you might imagine, with manure.
Well, they have manure ponds, right?
They have manure ponds. They will also dry the manure and spread it on top of the field. And it actually has nitrogen inside of it, so it can be a fertility source. So what we've done is we've developed a solution where we can take that water out of that pond that is actually super rich in nutrients.
Yeah.
Using this same automation technology, let's think about it simply, one pipe of manure water and then one pipe of fresh water. And the computer knows exactly what the dosing should be, like the percentage of manure water to fresh water.
Oh, wow.
The valve moves, it inserts this into drip irrigation tubing that now is delivered to the plant underground. So a couple things happen. One is, if you're putting dried manure on top of the soil, you're going to have greenhouse gas emissions. You are now able to deliver this underground, so you're not releasing greenhouse gas emissions into the environment. All of this is staying underground. You are also able to control exactly the amount of water that you use so that that manure doesn't leach through the soil profile. So you're protecting groundwater. No more nitrates in groundwater.
Because of the control of how much you're putting in there.
Yeah, otherwise these crops might be flooded. And if you flood irrigate this crop, I mean, you can't tell flooding.
You're washing away all that manure. You're washing away all the manure. Yeah.
And it's going into the groundwater. And then the other key thing here from a farming perspective is, in many of these situations, and most of these situations, they use the nitrogen from the manure and they completely eliminate the need for synthetic nitrogen. So that's a cost benefit for the farmer, of course, but it's also an environmental benefit because we need less synthetic nitrogen.
Yeah, and I would imagine that the process for creating synthetic nitrogen isn't all that friendly either.
Correct. Yeah.
Yeah, and you're not shipping it all over the place, so you're reducing carbon emissions and carbon footprint and scope 3 emissions and all that other kind of fun stuff. Does it, now you said, you're delivering this stuff through a tube underground, right? With the water, the manure specifically. So from those ponds, does that help? I guess that would help reduce the methane GHG, because you're reutilizing that and pulling out there. And most people don't understand this, but methane's like the worst GHG. It's like 80 times worse than like CO2. It's just shorter lived, right?
I don't know the science on that, but I'll take your word for it.
Yeah, no, look it up. It's like it's the bad stuff. People don't, I mean, it's there's not as much of it as the CO2, but it is like, as far as a greenhouse gas, it is far worse than CO2 as far as its ability to heat the earth, right? It just doesn't last as long in the atmosphere, but it is an issue in utilizing that in a way to keep it from going out into the atmosphere is fantastic. I mean, that's fantastic. So you can use that just about anywhere, right? I mean, you could bottle that and dose the system that you have in another farm that doesn't even have cattle, or cross leach it, or whatever you want to do, right? That is fantastic. I imagine that your impacts are tremendous, like you said, in California, et cetera. Are you guys global? Because these type of systems, like you said, out of Tel Aviv, there are places in the world where they're growing stuff where they really shouldn't be growing stuff, and it's very difficult to do, but they have to do it in order to feed themselves. This has got to be fantastic stuff for those type of areas where they're, in food deserts, right?
Yeah, we are a global company. I'll give you an example of another thing we do in Canada. Okay, so in Canada, there's a lot of ground, there's a lot of productive ground, but the weather may not always cooperate. And so one of the other parts of business that we're in is we're in the greenhouse business. And so we construct greenhouses utilizing our technology inside of the greenhouse. And we just finished a greenhouse a year or so ago up in Manitoba, Canada. So what would happen in Manitoba, of course, is just given the weather and the climate conditions there, they were largely reliant on imported produce, particularly in this case, tomatoes. So they're bringing tomatoes in that would typically be field grown, and they're bringing them in and trucking them in. So you have the impact of the transportation and everything else. And now what we have is this beautiful greenhouse where they are able to train the tomatoes so that they grow up towards the ceiling instead of out across a bed. So think of a vine going straight up to the ceiling full of tomatoes, and they can grow them 365 days a year locally in a sustainable fashion, creating jobs locally, eliminating this food desert that they've been in, that they've had to solve the problem by transporting tomatoes in. So that's another area specifically where we're taking areas that may not have historically been productive and solving the problem that we have about more people on this planet every single day. And by 2030, we're going to need to be able to produce a lot more food with less water, with less fertilizer, with less land. So we've just got to be more productive on every single acre to be able to feed the growing population.
Yeah, I mean, when I hear, like a hot house, I think of a bow house, right? Is that what we're talking about? Like bow houses, or are we talking about like warehouse? Because you could just build a warehouse.
No, right? This is all glass.
Yeah.
And this particular, and we do what you would call a bow house. We call them a hoop house. We do those as well. But this particular thing is 5 acres that's completely under glass.
Okay.
We're working on another one right now where they are taking heat from other processes. Specifically, we're looking at the Bitcoin mining industry. They generate a tremendous amount of heat that can be utilized in a greenhouse. And so we're looking now into applications where we can take that waste heat from a Bitcoin mining operation and utilize that heat to heat a greenhouse and grow food right next door.
And that's fantastic because you need the heat for the greenhouses, but you also need the cooling effect of a specific environment to run the Bitcoin operation as well, right? So you can have a really great little circular system going on with that. Bitcoin greenhouses.
Yes, new, up and coming.
That is fantastic. That is unbelievable. So how does this technology and what you guys are doing, how does it fit or work with other agri-plastics and et cetera? So like, the polymulch films that I asked you about. I know you guys don't do the polymulch films, but I would imagine your products go hand in hand with that as well, right? I mean, together they really kind of solve some issues, no?
Typically in that case, what would happen is your drip line would be under the soil. They would shape the bed for the plant, tomatoes, whatever you might be growing on there, strawberries, and then they use that mulch right over the top of the bed, primarily to prevent weed growth. So
Right.
there's a lot of work that's going on right now in R&D in how do you take all of that mulch and the drip line and everything out of the field at one time to recycle that, versus today what's happening is they're recycling the drip line that's coming out of the field, but not necessarily the mulch.
Yeah, I would imagine the mulch has a lot more biomass and dirt, et cetera. I mean, it's a lot more contaminated, much more difficult to deal with.
It's just a different process. I think the other key thing that's important, obviously, is when you're moving things, there's a cost associated with moving them. You don't want to move them great distances. So with the drip line, we're able to bind it up really, really tight in a giant roll. And we build our recycling facility, like I said, around Salinas Valley, where it's not a long transportation time to get it there. And so it becomes cost efficient. The biggest
the logistics can get you pretty quick.
Exactly. And the biggest challenge I think that's facing farmers today around adopting more sustainable practices is there's a cost implication of doing it. And these are businesses, and in many cases, small businesses that have to turn a profit. So even our technology, when you go and put in a full drip irrigation system versus opening a valve and flooding a field, you can imagine it's more expensive to install all of the drip line and the filtration and the valves and everything for our system. So there's a couple of things that happen there. One is sometimes you look at it in two ways. Water scarcity is one way. Sustainability might be another way. But a third way even is return on investment. And so typically what happens with drip irrigation is you can use about half of the water and you can generate yields that are sometimes 2x what you might have without drip irrigation. So now the cost benefit equation is different. And that typically plays out on what we would call a high value crop. One of the challenges that we're running into right now is think of a lower value crop, and one that I talk about a lot is alfalfa. And anybody in the Western United States, and specifically in Arizona, has probably heard there's a debate going on about alfalfa and how much water it utilizes, and the fact that there's less water in the Colorado River. The reason alfalfa uses so much water is it's flood irrigated. So if you were to take the alfalfa and irrigate that water with subsurface drip irrigation, you can use a fraction of the water. In fact, the math says that if we took 20% of the alfalfa acres in the Western United States and converted them to drip, we would solve the problem and save all the water that people want to save off of the Colorado just by making that conversion to drip.
Holy mackerel. That's amazing. So why won't they why not why wouldn't governments, subsidize that to make that happen?
So this is the question, and there is some of that happens. The process is fairly complex, and the funding is typically oversubscribed, so that there's only a certain amount of funding out there, and the farmers can't always access that funding. One of the things that we're doing is we have a government and regulatory affairs group that's working directly with farmers, helping them to understand how to access that funding. We actually have on our website, we have a farmer portal where we will guide them towards places where they can find that money to help offset the capital infrastructure that is needed to install a drip irrigation system.
Is that at netafim.com or is that at Orbia?
It's at netafimusa.com.
There you go. Okay. Just wanted to put that in there real quick since you were mentioning they could go to that portal.
Yeah, absolutely. And then we're also working on the front end of this with the people that are setting the policy and the policymakers and saying, okay, what's happening today? What's happening today is we're saying there's not enough water to feed the farmers, to give them enough water to grow if they're dependent upon the Colorado River. And so what is the government doing in many cases? They're saying, I'm going to pay you not to farm. And if you quit farming, then we're going to save water. So our push is we can't not farm because there's so much population growth that we need farmers. And so instead of paying farmers not to farm, why don't we help farmers subsidize the cost of the technology that allows them to farm in a more sustainable fashion? So this is really a big push of ours.
Yeah, no, it makes too much sense in many cases for, well, we won't get into that. The saying, you're making way too much sense, right? I mean, so when my next business application, you say, hey, I'm going to go start a farm down in Phoenix. And then they'll say, listen, we'll pay you $100,000 to not do that.
Yeah, exactly.
Right?
Yeah.
That doesn't make a whole lot of sense. I think it's really important. And one of the things to get out of this is, it isn't a convenience factor, right? Like you and I were talking about prior was, hey, throwaway culture, right?
Right.
And you said this isn't the case. It may have been in the beginning something along those lines when it very, very first started, but it doesn't seem that way. It seems, for instance, I mean, the whole consumer plastics is built on convenience and extraction, use, throw it away, single use, get rid of it, right? This single use actually produces something. Plastic bags instead of paper, and you can argue which one's actually better for the environment, but it was just a convenience thing for me to move my groceries from one place to another, right? Mm-hmm. This is actually, and I've heard it before, 30% to 2x, depending on the crop, is the ROI on using these. And like you said, we can't afford to not use this technology.
Yeah, for sure. And
it's devastating.
And if you look at just what's happened globally, for sure, and what we're continuing to see in the U.S. agricultural market, particularly in the Western United States, is we need to make more food. We need to produce more food. And there's just less water. I mean, there's more people using water because of population growth just in our households. We have to be more efficient with the water that we utilize for farming. And we have times when we're running through a drought period. And what's happened in the Central Valley of California in many cases is when we've run through these drought periods, or when we've not been able to access surface water the way in which the farmers have typically relied on surface water, they move to pumping groundwater. And so that's okay in short doses, but when you become over reliant on that and you don't have that supplemental surface water as well, you begin to deplete aquifers. And so again, this means we need to start irrigating or continue irrigating in a more efficient way. There's already a high degree of adoption of drip irrigation in specialty crops in California, but we need to move these into the corn crops, into the alfalfa crops, into the crops that wouldn't typically utilize drip irrigation, because we have to do this to keep farming, or we're going to be putting farmers out of business because there's just not enough water.
Yeah, that's one of the things I looked at before, and I'm glad you brought that up, is like the Midwest covered up with obviously wheat and corn. It's just not, this technology isn't used typically in that. Is there a reason why they haven't adopted this and why it's kind of they lag?
Typically, it's not adopted because they have rainfall and they don't even need to irrigate. But then when you do go out and look at irrigation, typically in that neck of the woods, you're going to see pivot irrigation, the big long sprinklers travel in a circle, right? There's a difference in cost between a pivot irrigation system and a drip irrigation system. But I'll tell you where we are really starting to see traction in the Midwest has nothing to do necessarily with water conservation. It goes back to what I said about delivering the exact amount of water at the exact time that the plant needs it. Now take that a step further and think about ourselves. Think about medicine. So you've got veins that are running through your body. And when you go to get vaccinated, the doctor puts a needle in your arm and puts medicine in your arm, and it moves through your body. Now think about a drip line in a corn crop as the veins running through your body. You can go anytime that you want and put fertilizer through that. And now you're delivering the fertilizer not in a broadcast way across the field. You're delivering it underground to the roots of the plant exactly when the plant needs it. So we're seeing adoption of drip irrigation, not because they need water, but it's a more efficient delivery system for fertilizer and nutrients. So there's less waste, more sustainability.
And I would imagine that there's also, like, before, on top of that, there would be some sort of ROI effect. I mean, if you're applying science to your production, you've got to be improving it, right?
Absolutely. You want, I mean, what's the simplest way to look at it is you're not wasting fertilizer. You're not broadcasting this across every single acre. You know exactly that every ounce of fertilizer that you're utilizing is going to the plant and to the plant's roots, not in between the plants, not in between the rows, exactly where it needs to be.
So the plant's healthier and your costs are going down.
Correct. Costs are going down, yield is going up. Absolutely. So it's a win-win.
So is this technology being does it proliferate around the world into areas where they need it?
Yeah. Anywhere where there's farming, anywhere where there's irrigation, you're going to find Netafim. We produce material all over the world. We are the world's largest irrigation company, bar none. So every place there's farming, you're going to find something that is going to be utilizing Netafim.
That is fantastic. That is fantastic. So how did you fall into this? I know your background is I stalked you a little bit on LinkedIn, so I know you came from Dow, et cetera. Have you always, even there, were you in the development of irrigation, plastics and polymers, et cetera? Or how did you fall into this? Or was this like an epiphany that said, look, I got to get involved and make this happen?
Yeah. So irrigation, but I'd say more around agriculture is the background for myself and my family. So I'll go back to the Dust Bowl. My family, literally, this was grapes of wrath. My father, when he was a very young child, moved from Oklahoma to California during the Dust Bowl. And he ended up working as a sharecropper with some farmers in the California area. So our family has roots in agriculture. I went to school and got a degree in crop science and did my master's coursework in agronomy. And following that, I got involved in the seed business and the crop protection business, herbicides and things of that nature. And I did that for about 25 years or so, 25, 30 years. And I was looking for an opportunity to do something different. Netafim's North America headquarters is right here in Fresno, California, which is where I live. My father-in-law was actually my irrigation professor in college.
Oh, wow.
Yeah, so it's all coming full circle. And for me, as somebody looking to, number one, be a part of agriculture, contribute to doing good in the world, and thinking about a career, we're not going to have more water. So for the rest of our lives, water will become a bigger and bigger and bigger issue. So if you just look and say from a job security standpoint, we need people working on how to utilize less water, not more, and farm and grow more crops and help farmers be more successful. So for me, a lot of things met in one spot.
So that's awesome. That's awesome. I love it because a lot of people have this epiphany, but most people that I talk to, I mean, they grew up in this environment. It was their culture, and it really gives me a lot of obviously hope, but it makes me feel very positive about the future and the way we're going, because more and more, like, my kids are exposed to this constantly, right? I mean, I grew up in the 70s, man. I mean, there was no what environment. What's that? You know what I mean? That's, what, we had acid rain and we loved every drop of it that came down on us. But now, people are growing up in this and it's moving forward. So there's more and more support. And you see it in the choices that people make and the demands that they're making on industry, right? Yours happens to be an industry where they demand it to produce more and higher quality, and they demand it to be done with less and less, harmful chemicals, pesticides, fertilizers, et cetera. And by the way, you can't use as much water as you had before. So here, good luck with that, Mike. And it's nice to have, I mean, it's not nice, it's essential to have people in companies like Netafim out there doing stuff and making this happen. It's really awesome. And I thank you for coming on. Where are you guys at as far as, and if you're not or can't say, that's fine. It could be, maybe you're under the radar on some certain things, but, I had people on the show that are doing, like urban farming and stuff like that, and rooftop farming and all these, hydroponics and stuff like that, these new way of doing hydroponics in like downtown Philadelphia and stuff like that are highly scientific. Like you're talking about these, they're growing these plants and their roots aren't even in. They're just spraying them with water and nutrient. They're not even in soil in these greenhouses. Are you guys in developing that type of stuff and into that type of thing as well?
For sure. So there's a couple angles there that we're involved in. One is our core business within Netafim. The irrigation components that we utilize for any type of growing can be utilized there as well. So aeroponics is what you're talking about.
Aeroponics. That's exactly it. Yeah.
We're also involved in hydroponics. So the raspberry grower that I used as an earlier reference, that was a hydroponic situation that we were in, where they're using soilless media and in a pot instead of actually planting into the ground. So there's lots of advantages to those. So we get involved in that in Netafim. I mentioned earlier Orbia. There's another business that's a part of Orbia called Waven. And our business Waven is very involved in rooftop gardens. So they have the technology for rooftop gardens. They have technology for the tree wells, where you can collect the rainfall in a tree well and be able to utilize that to water the tree instead of having to have irrigation that's piped to that tree. That technology is also used in rooftop gardens. So our company is very involved in that space.
Okay, cool. Because I find that very, very interesting. There's arguments there as well, like what crops should be grown there, what shouldn't be grown there, blah, 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 based on, what needs to be trucked in or what, long distance trucking in. Yeah, you probably should grow those in the urban, but those that aren't, maybe not. I don't, it's use of space, et cetera, that type of stuff. I remember there was a point where I read an article about, how Walmart's going to, be 2 stories now, and they're just going to be growing the produce on top of the store, right? And just bringing it down. And that's really not crazy with the technology you guys have, right?
Yeah, we see a lot of urban farming. I mean, it's something that really, I would say a lot of this took off during the pandemic. I don't know about you, I'll just speak for myself, but I was probably in more of a mode that when work was done, I'd go buy something from takeout to bring home and eat. Now, all of a sudden, we had this pandemic, and I found myself cooking at home more often than I had been in years and years, right? And so when people are cooking at home and they're touching the food and they're feeling the food, they say, where was this grown? And how was this grown? Was it grown in a sustainable way? And now we see that consumers, you said it earlier, I mean, consumers are voting with their pocketbook, and they're saying one of 2 things. In some cases, they're saying, I'll pay a premium for this produce because I know it was grown in a sustainable fashion. In other cases, they're saying, I'm not even going to buy this stuff unless I know how it was grown. So there has certainly been a rise in sustainable farming, in local farming. Yeah, since a pandemic, and it's a part of our business that's a very important and growing part.
Yeah, the disruption of supply chains impacted every aspect of our lives. Yes. And certainly, nearshoring of manufacturing or supply chain for raw materials, parts, etc. That's hey, buy local produce, right? Same thing. Nearshoring, near agriculture, I guess you want to call it, or something like that, right? Exactly. Is important to people, or grow it yourself in the backyard, right? Yep. It's tremendous stuff. So, any last thoughts you want to send out there, Mike, or plug, or what's coming up with Netafim?
No, I just say that the thing I'll leave people with is, I'm a quote guy, and I'm probably going to mess this one up, but I'll do my best. There's a
we'll
quote.
Blame it on someone else.
Yeah, exactly. There's a quote out there that talks about what we need as human beings. And they say, there's a few times in your life you're going to need a doctor, you're going to need a lawyer, you're going to need a policeman. But every single person on this earth, every day, 3 times a day, needs a farmer, because we all need to eat. So there's a lot of people that are a bit, I'll say, disconnected from the day-to-day and the food supply in terms of having to do the work. But everybody is connected to our food supply in some way, shape, or form. So I just encourage people, support your local farmer, vote with your pocketbook, buy the sustainable brands, buy the sustainable produce. There are choices, and we all have choices.
Fantastic stuff. I appreciate it very much, Mike. Everybody, hey, thanks for downloading and supporting the Sustainiacs, and we'll catch you next time. Peace and love.